Hello everyone. Our question for today is the following integral. 1 over x into x plus 1, etc. up to x plus n. Since the integrand is a rational expression and the denominator is a product of linear factors, we first have to use partial fractioning in order to decompose this expression. But the number of the factors in the denominator depends on n, and we do not know what n is. So how would we decompose this fraction? In order to answer this question, let us start with particular cases for n and try to find some pattern as n increases. If n equals to 1, then we have 1 over x into x plus 1 is equal to a over x plus b over x plus 1. We find the common denominator. Then we end up with the following expression. In order to find the values of a and b, we replace x by the zeros of these factors, which means x equal to minus 1 and x equal to 0. And this is what we get. A equals to 1 and b equal to negative 1. Following the same scenario, we get the following for n equal to 2, this for n equal to 3, and so on. So our task here is to find some pattern of the coefficients of the factors in the denominator. To do that, let us first write the fractions as follows. As you can see, the signs of the coefficients are alternating. That is the first feature of these numbers that we can catch. Let us now write all these numbers separately and try to see what's going on. I'm going to ignore the alternating sign feature of the numbers for the moment. So for n equals to 1, we got the two coefficients 1 and 1. For n equal to 2, we get 2, 1, and 2. For n equal to 3, we get 6, 2, 2, and 6, and so on. We can write these numbers in a different way. I'm going to write the first one as 0 factorial times 1 factorial, and the other one as 1 factorial times 0 factorial. 2 as 0 factorial, 2 factorial, 1 as 1 factorial, 1 factorial, and the other 2 as 2 factorial, 0 factorial, and so on. As you can see, we are always starting with 0 factorial times n factorial. Then we keep adding 1 to the first number and subtracting 1 from the second number. So 0 becomes 1, then 2 up to 3, and 3 on the other hand becomes 2, 1 down to 0. And it will keep going like that for any positive integer n. This means that for any n, the first factor will be 0 factorial times n factorial. We add 1 to 0 and subtract 1 from n. We get 1 factorial n minus 1 factorial, then 2 factorial times n minus 2 factorial, and so on up to n factorial times 0 factorial. Let us now come back to the alternating sign. The first term has a positive sign, the second term has a negative sign, the third is positive, and so on. Let's call the first term a0, the second a1, and so on up to an. Thus, if the index of a is even, the sign is positive. And if the index of a is odd, the sign happens to be negative. Therefore, after having all this information regarding the coefficients of the factors in the partial fractioning expression, we can say that the general form of the terms is the following. If k is even, then minus 1 to the power of k is plus 1. We start with k equal to 0, and we keep subtracting k from n up to k equal to n, and the results match with all the coefficients that we have. We now come back to our fraction, and it can be expressed as the sum of the following fractions. So now we can easily integrate this expression. We will have a sum of logarithms. The integral of this expression is the sum of the following integrals, and this is the final answer. Thank you for watching, and see you in the next video.